Okay, so this is homework 9, problem 4. And this problem says a constant force of 56.7 newtons directed at 26.3 degrees from the horizon pulls a mass of 14.9 kilograms horizontally, a distance of 2.61 meters. Calculate the work done by the force. Okay, so basically in this problem, we have an object, let's just say a box. It's on a flat surface and it's being pulled at a constant force, but that force is not straight. It's not perpendicular, or sorry, it's not parallel to the floor. It's actually being pulled at an angle. This is 56.7 newtons, and that angle is 26.3 degrees. The mass is equal to 14.9 kilograms, and the displacement, D, is 2.61 meters. And then it says, what is the work? Okay. So work, again, is equal to the force times displacement, and it's only the component of the force in the direction of displacement. So for instance, in this picture, our force is at an angle, right? And our displacement is purely in the x-axis, right? So we need to, we'll draw our free body diagram. This is this force, 56.7 newtons. This is at this angle, 23.3 degrees. So we can break this down into its components. We have an x component, right? So force in the x, and then we have a y component, the force in the y. So the way you solve this, so f of x is just gonna be 56.7 newtons times the cosine of theta, which is 26.3 degrees. The way I solve that is to say cosine theta is equal to adjacent over hypotenuse. Our hypotenuse here is 56.7. The adjacent is what we're looking for, and then we have the cosine. So if we multiply both sides by the hypotenuse, we get hypotenuse cosine theta is equal to adjacent, which is 56.7 newtons cosine of 26.3 degrees is equal to this component here, okay? And so that is our f of x. What is our f of y, question mark? Well, it's f of y is just 56.7 newtons times the sine of theta, okay? Now, the force, so the work equals force times displacement. The force that we're interested in is not the y, it's actually this force. It's this force in the x direction, because that is the direction of our displacement, right? So we can say the work is equal to 56.7 newtons times the cosine of 26.3 times the displacement, which is 2.61 meters. So 56.7 times cosine of 26.3 times 2.61. So the work is 132.668 joules.